So next we have your D quantifiers. The first one is the universal quantifiers uses none, no, all, and every in a statement. Quantifiers none and no denies existing of something, whereas all and every asserts that every element of a given set satisfy some conditions. The universal quantifications of P of X is the proposition in any of the following forms. P of X is true for all values of X. So we have for all X, P is a function of X. For each X, P is a function of X. For every X, P is a function of X. Given any X, P is a function of X. All of them are symbolically denoted by inverse A, X, P, which is a function of X, which is pronounced as for all X, P is a function of X. The symbol inverse A is called the universal quantifier and can be extended to several variables. So we have your statement. The statement for any real number x, we always have x squared is greater than or equal to 0. It's true symbolically, we can write for all values of x, it is the element of a real number such that x squared is greater than or equal to 0. Or for any values of x such that x, the element of R, or the real number, implies x squared is greater than or equal to 0. The second form is a bit wordy but could be useful in some situations. Next, you have your D existential quantifiers. Uses some and there exists and at least one in a sentence. The existential quantifications of P of x takes one of this form. There exists an x such that P is a function of x. For some x, P is a function of x. There's some x such that P is a function of x. We write in symbol inverse E x P, which is a function of x, which is pronounced as there exists x such that P is a function of x. The symbol E is called the existential quantifier. It can be extended to several variables. So we have your example, the proposition. There exists a real number x such that x is greater than 5. Can be expressed symbolically as, okay, there exists x, which is the element of a real number such that x is greater than 5. Or there exists x such that x is the element of a real number and x is greater than 5. Notice that in an existential quantification, we use the n symbol instead of implies to specify that x is a real number. So this is our summary. Operator, conjunction, the end statement. Ito yung symbol po niya. True only when both P and Q are true. Next, disjunction. P or Q. False only when both P and Q are false. Next, we have your D, negation. Ito po yung symbol opposite truth value of P. Then last, we have the conditional, the F and then statement. P implies Q, false only when P is true and Q is false. And also, there are two ways to quantify a propositional function. We have the universal quantification and existential quantification. They are written in the form of, for all values of x, P is a function of x, and there exists x, P is a function of x, respectively. To negate a quantified statement, change the existential, universal to existential, and existential to universal, and then negate the statement. Okay? So that ends your week 12. Thank you.